So I first started teaching SysML in 2013 at University of Southern California. This was a full semester, 16-week course. And one of the projects that my students could choose was to design a mosquito killing laser that only killed mosquitoes and left all other flying insects alone. So we've since nicknamed that system VS-RADS for Very Short Range Air Defense System. And I'm going to use it here to illustrate basically how to follow an object-oriented systems engineering process. So the basic idea of this system is that after we power it up, it's going to detect mosquitoes, kill the mosquitoes, do some damage assessment, and it can also display status. Requirements here can sort of segment into weapons requirements. So it has to kill mosquitoes, and it has to only kill mosquitoes and ignore other insects. It has to detect mosquitoes, track and target them, and it needs power, and it's got some environmental conditions it has to satisfy. We can look at this on a requirements diagram like so, same requirements as we have in the table. And then we did a domain model for this. So this is a conceptual problem domain description of how we would kill mosquitoes with a laser beam. So we've got a microcontroller and a housing and some sensors. We have audio sensors that we're going to use to detect the whine of the mosquito. And then we have some cameras and a little rotating mount that has an infrared emitter and a kill laser on it. So we can look at the state machine for the microcontroller. That's a kind of an interesting state machine. It cuts across all the use cases. So basically, when we power the system on, it's going to listen for targets, and that means we're going to pull our audio sensors to listen for the whine of a mosquito. And then once we've identified it, we're going to paint that target region with an infrared emitter, and then use our cameras, once we've illuminated it, to track the target more precisely. We're going to compute a projected target track and then fire our kill laser to incinerate the mosquito. When we detect a thermal flare, we can do some damage assessment. And if we see a thermal flare dropping straight down, then we can call that a kill. So we can generate a requirements versus use case matrix, and you can see right now we haven't in our design accounted for displaying any status. We don't have any requirements about that yet, so we got some work to do. We can start writing the use cases, and we're using the Cameo use case profile. And when we write use cases, we are highlighting the domain objects, the nouns in this scenario, in bold. And so we have essentially the basic flow, which is the sunny day scenario, and then we have some alternate flows and some exception flows. And we can map that out on an activity diagram. On this activity diagram, we haven't yet handled the exception flows, but we have them on there as a reminder to not forget them. So how does it work? We're going to listen for mosquitoes. That means our audio sensors are going to send some signals. And if we detect the mosquito wing beat frequency, we're going to kind of localize a target with our array of microphones. We're going to turn our rotating mount toward the target. We'll paint the target area with infrared light, and then we'll use our cameras to image that target area, get a more precise target location. And that is pretty much the end of the normal scenario for detecting mosquitoes. Well, when we started writing this use case, we started using some other nouns that we didn't put in the original domain model. And a lot of those nouns are actually software objects, so we don't have any hardware that is a target or a track or a projected track. But when we start writing the details of how to build this use case, we find that we need those. So since they are basically objects in the problem domain, we add them to the domain model. And in this case, to just kind of highlight what's happened, we color coded them to say these are software objects that we discovered while writing the use case. If we go back and look at our requirements traceability now, we can see that all those new software objects don't have any requirements allocated to them yet. So again, we have more work to do. After we've finished our stakeholder needs analysis, we can start a logical architecture, and you can see the logical architecture resembles the domain model, but it's a little bit different in that now we've layered in some subsystems on top of our domain model. So now we've got a fire control subsystem. And you'll also see that there's some operations and signal receptions showing on the various blocks here. Well, how did those operations and signals get there? They got there by drawing a sequence diagram, sending messages between our objects, and using Cameo's feature that allows you to assign that signal reception to the rotating mount by just clicking on the button. So we're basically moving from a pure requirements and use case and domain model view of the world into a logical architecture, and from there we'll move forward